Hello everyone. Today we will study a very important concept which will help you in solving the numericals in mechanics, and that concept is free body diagram. So as the name indicates, what is a free body diagram? Free body diagram. So here the body is considered as a point object, and we mark all the forces which are acting on that body by the other parts of the system. Then we apply the equations of motion and solve it, right? So in short, if I want to define free body diagram, I'll define it as, or you can say FBD, that is free body diagram, is a diagram showing the body as a point object with all the forces acting on it, right? But how to draw that? There are some systematic steps we need to follow to draw a free body diagram. Now what are those steps? Steps to draw an FBD, right? So this we can write in short FBD. So the very first step is show the object under consideration as a point object. And if we have two or more points, two or more bodies, then draw a separate FBD for each, considering it as a point object. Right? Then what is the next step? Mark all the forces acting on the body, right? Then use Newton's laws to write the equation and calculate the unknown. To write the equation and calculate the unknown, right? So to understand this better, we'll have to take an example which is given in your NCERT, right? So let's take that example. This is example 5.9. It's given on page 102. Page 102 NCERT. What does it say, beta? It says that what is the acceleration of the block and trolley system shown in the figure. So you are given this system. This is the trolley, okay, and this is on the surface. There is a pulley attached to this surface, and there is a string which is passing over the pulley, and here it is attached to a block, right? And what else is given? If the coefficient of kinetic friction between the trolley and the surface is 0.04, which direction will be the direction of kinetic friction? If this system is moving this way, right? So the kinetic friction will be opposite to that. What is the tension in the string? Now let's see, beta. This string is in taut position, खींची हुई है. So what will happen if this is the mass of the block, which is given as 3 kg, right? And its mass is given 20 kg. Right? I told you that tension is always marked away from the body. So here in this string, the tension is marked away like this. Here in this string, if I am considering this as point object, this is marked away from this. The weight will be downwards, and this will be, if we take G is equal to 10, so this will be 3 into 10, this will be Newton. Why so? Because kg meter per second square, that means 30 Newton, right? Now, what other forces are acting on this? The weight of this trolley downwards, and this will be 20 into 10, that means 200 Newton. Same way, this is kg meter per second square, right? And normal reaction normally outward to the surface, I told you in the previous video on normal reaction and tension, right? Now, what are we discussing? We are discussing the free body diagrams. So that means what? How many bodies are here? Here we have 2 bodies. So we'll draw a separate free body diagram for each of the body. So each body we'll consider as point object. So right now I am taking this trolley, and for the next free body diagram I am taking this mass m. I am drawing separate free body diagram for first mass and the second mass. What is the next step? First step was consider each body as a point mass. What was the second step? Second step was mark all the forces acting on the body. So let's check this. This is mg. This is normal reaction. This force is tension. So this force is tension, and this force is kinetic friction, which is acting in the opposite direction. Now let's check this mass. How many forces are acting here? The first force is the weight, that is small m into g, and this is the tension, right? We know that this total system is connected to each other through this same string. That's why this tension is taken as same, because tension is same at every point of the string if any other forces are not interrupting here, right? So here, now what will we do? We will write the equations using Newton's law. Now they are asking for the acceleration of the system. So what the question is asking, you have to find the acceleration of the block and trolley system, right? So this is what we have to find out. Now let's check out. This system is connected to each other. Now if this is moving down, so this system will also move this way with the same acceleration since these are connected bodies, right? So here in the free body diagram, I need to specify this also, that the acceleration in this case is in this direction. And in this case, the acceleration is this way, right? Now the next point is very, very important, and that is free body equations, which I told you we'll use Newton's laws to write the equation. So now the free body equations, right? If we are taking for first case, right? For first case, let's check out, is there any vertical motion for this cart? Is it moving in the air? It's simply moving horizontally. So that means these forces are balancing each other. So you can write first equation as R is equal to M into G, right? So you can write R is equal to M into G is how much? 200 Newton we had calculated, and here it is 30 Newton we had calculated. So this is 200 Newton. This is the first equation, okay? Now any other equation which we can make here? This was for vertical. Now for horizontal, we can use Newton's second law. Second law says that net force is equal to mass into acceleration. So which net force is acting this way? It is moving this way. So net force is acting right side. So you can write T minus Fk is equal to mass of which body? The body for which we are writing the free body diagram. So this will be capital M into A. I hope this is clear. So here this I'm leaving it as it is as of now. I'll put the values later on. Okay. So I'm putting this as equation 1, suppose this as equation 2, and let's solve the rest part here. Now free body equations for second case. Now what equation we have to make? Net force along motion is equal to mass into acceleration, again by Newton's second law. So which one will be greater? This will be greater because the system is moving this way. So you can write mg minus t is equal to mass of this body into acceleration. And we also know that here this mg is what? 30 newtons. So first we will solve this. Simplify and then put the values. This is the third one. So let's add these two. So this will be equation 1 plus the equation 2 plus equation 3. So this will give me mg minus fk, because this t will be cancelled, is equal to m plus m into a, right? Let's mark this as equation 4, right? We have to write the value of fk also. They have given that the coefficient of friction is 0.04. This is given, right? So how to find this fk? We know that fk is equal to mu k into r, right? And r is how much? 200 Newton. So let's mark this as 5 from 1. We are putting the value in 5. So what will be Fk? Fk will be 0.04. This is given in the question, plus multiplied by 200. So this gives me, let me solve it. So this gives me, so this is 8 Newton. So let's take this as equation 6, right? So from 6 in 4, small mg value, I know that this is 30 minus Fk is 8 is equal to capital M is 20 plus small m is 3 into acceleration. So let's solve this. This is 22 upon 23 meter per second square, and this is what was asked in the question. So the most important thing is this, which we have drawn here. This is your free body diagram for first body. This is your free body diagram for the second body, and then you have these free body equations for the first case and the second case, and then you have solved these things. I hope the concept of free body diagrams is clear. That's all for now. Have a nice day.